Hello everybody and welcome to another talk. Today I wanted to talk about questions that fall too short. Again and again I can hear my friends and my classmates discuss questions about 5G and other mobile phone and WLAN fields and their impact on our health. These questions are starting to annoy me because they all fall too short. If anyone wants to discuss 5G and the effects on health of humans and, this is crucial here, or similar long-living species, one should consider all artificial electromagnetic EM radiation, and not just a small frequency range, which is the millimeter wave range for 5G, for instance. Thus, this whole sounds like a very interesting topic. So as always, let's get right into it.
At first we ask, what does the established science, respectively the contract research, say here? The question of the possibly harmful influence of EM radiation on humans is usually investigated and answered in two ways. By the official and usually politically and industrially controlled research, A, via animal models, and B, through theoretical models. In case A, often the mouse model is used, whereby the basic problem is that mice do not live as long as humans. It is unknown how the radiation thus would have to be adjusted in time and strength to at least come close to humans. And furthermore, it is not clear whether mice, because of their shorter life expectancy, can even develop the damage that can occur in humans with long-term exposure to EM. In plain English, the industry researchers can always set up their mouse model in such a way that the result is guaranteed harmless for humans. This is cheating at its best. It is similar with all other animals and tissue models. In case B, the influence of EM on certain larger molecules, proteins and DNA, is investigated with supposedly highly accurate molecular dynamic models. But there, the following problem comes up. In order to be able to do the computational work at all, the theorists have to make simplifications in their models. They do this, for example, by cutting down interaction potentials above a certain size. Or they use so-called tight blind techniques in order to only have to consider a small, in their opinion decisive, part of the atomic interaction. De facto, in order to use an image, they then calculate in an approx. 1 centimeter wide range of interaction scales that in nature cover over a kilometer. With very simple experiments, one could easily show that nevertheless there are effects in practice, as the attached picture with two identically aged and identically used student ID cards proves. Both ID cards were scanned in the same process and treated completely identically. That is not at all. In terms of image processing, apart from the necessary obliteration for data protection reasons, the only difference in handling is the storage during the 4 months of the ID card's life. The left ID card was stored in a school bag, the right one in the cover of a mobile phone. The fading effect on the right picture speaks volumes. Where can the damage be generated in human tissue? Well, interestingly, in the area of valence interaction, that is the interatomic bonds, the industry researchers really do not find any evidence of damage from the usual EM radiation as emitted by the mobile network. Here, the electromagnetic waves are simply not strong enough to sufficiently disturb or even break the bonds between the atoms in the molecules. One thing, however, seems to be ignored by certain contact industry researchers, and that is the so-called molecular folding. This structural formation of proteins, which is so immensely important for the biological function of proteins in the long term, leads to such evil diseases such as Creutzfeldt-Jakob in the case of errors, so-called Broyne errors. Since the manifestation takes place in periods of 1 to 2 decades, it is no wonder that animal models, especially those with short-living species, do not show this damage. Folding, however, takes place at much weaker interactions, van der Waals interactions, and thus may well be disturbed by the usual EM fields around us. Can the damage be generated in genetic material as well? First of all, the genetic repair mechanism that is necessary to maintain our health is particularly dependent on correctly folded proteins. If damage occurs here, it looks bad for the prevention of cancer and the like. In addition, the author suspects that nature, contrary to what established science thinks, has not only encoded information in the sequence of the base pairs of our DNA, but also uses the folding of the hereditary substance molecules in the chromosomes as storage. The reason for the assumptions are the following. A. Nature does not waste anything. B. Nature always uses its own inventions several times, and the folding plays such a big role in the proteome, which is in proteins. Why not in the genome as well? And C. Evolution needed a gigantic period of 1 billion years to perfect cell division. Why should this have been so difficult if the only thing that had to be done was to split the DNA double helix and then to add the appropriate strands to the resulting single strand? Why the complex structure of chromosomes as folded DNA? Why the central bodies on their role in the unwinding of chromosomal folds? Why the cell aging determining function of the telomeres, which are the protective caps on the chromosomes? And there are many more such questions, of course. Conclusion. Where the contract's research is not looking, there could be considerable health risks lurking due to the now ubiquitous artificial electromagnetic radiation. Since the damage accumulates in the long term and does not cause any specific EM-related diseases, but rather normal things like cancer, allergies, and gradual cell degeneration due to telomere damage, leading to accelerated aging, the damage can always be easily hidden by government and industry statisticians in the overall poor health of humanity. And how do you protect yourself? Well, as long as no one really wants to see anything, nothing will be seen. And because you can't stand in the way of technology alone, you should at least try to keep certain things at a distance. Well, I definitively don't want to live next to a 5G tower. But actually, I don't want to live in the vicinity of a classic telecommunication transmitter either. I keep the mobile phone at a distance from my body, so I prefer to use the loudspeaker function. I put it far away when I'm not using it, and I don't put my laptop on my lap.